we have a question here on electrochemistry, which has come in JEE Mains 2025, which is last year. It's a very interesting question on the Nerst equation. Let's have a look. The question says that the standard free energy of formation of AgCl at 25 degrees Celsius is minus 109.7 kilojoule per mole. And they've also given us that the H positive and Cl negative ion, the free energy of formation is minus 131.2. The E naught is what they want you to calculate. So you know, the moment you see a question based on E naught and Gibbs free energy, there is a relationship which relates the two of them. And that is that Gibbs free energy is equal to what? Minus NF E naught cell, right? Where G is your Gibbs free energy, N is the number of electrons involved, F is Faraday, and E naught is what they have asked us to calculate, the electrode potential, right? So here, E naught we are calculating, the value of F we already know. We need to basically calculate this G. If we can do that, Gibbs free energy, I think our question is pretty sorted. And you know from thermodynamics that Gibbs free energy of formation, if you have to see, that is what? The summation of the Gibbs free energy of the products minus the summation of the Gibbs free energy of the reactants. So to know the products and reactants, I will have to write the reaction first, right? So here what is happening is the AgCl is there along with She, their standard hydrogen electrode, right? So here hydrogen, what happens, this is a reaction happening at the anode, all right? At the anode, the hydrogen gets converted to H positive and electron. You can balance this out. So I'll make this a half H2. At the cathode, what is happening? At the cathode, basically, AgCl is there. And here it's gaining an electron, it's getting converted to Ag and Cl negative. When I add both the reactions, when I'm adding both the reactions, I basically have to write the reaction in a way that the electrons can cancel out, which they have. So now this becomes AgCl plus half H2, giving me H positive plus Ag plus Cl negative, right? This is what it's giving me. You know, the standard Gibbs free energy of formation in the standard state, when the elements are in the standard state is taken as 0. So here for hydrogen, H2, it will be taken as 0. For Ag, which is solid silver, will be taken as 0. What are we left with? AgCl, the value which is given in the question, H positive and Cl negative, which is also given in the question. So what will I get here? For AgCl, the value given to us was, minus 131.2 minus 109.7, which when you solve will come out to be equal to nearly like a 21.5 kilojoule per mole. I have gotten the G value. And now I know G value, after having the G value, I'll put it here, which is how much? It will be coming out to be negative. So negative will cancel out. So 21.5 kilojoule. Please convert that to joules by multiplying with 10 to the power 3. How many electrons involved? 1. So value of N 1. Value of F 96500. And E naught is what we're calculating. When you solve here, you will get your E naught value as equal to 0.22. And they had given us N into 10 to the power minus 2. So I'll make 0.22 as 22. It was an integer type question and the answer to the question was 22.